Hello, everyone. I am Lee Jinwan lecturing on deep learning at Global AI Academy. I will be teaching you TensorFlow and Keras so that you can learn what deep learning is and how it works, and you can practice with actual codes. Today, we will start with what machine learning is, and then talk about what artificial neural network is for deep learning, how it works, and lastly about the mechanism for training the neural network. First, what is machine learning? I have a simple example: active recognition. Let's say we need to build a model that recognizes a certain action or activity. If a person is walking, the model has to be able to perceive the person walking. Then, the speed will be an important feature for that. Let's assume that we defined the speed lower than 4 as walking. But there is one more action. Let's say running is better. If it's lower than 4, it's walking. Otherwise, it would be perceived as running, because we have only two actions. Then, let's say here comes another action, biking. So we need to add that one. Speed lower than 4 is walking. If it's not lower than 4, but lower than 12, then it is running. And in all other cases, it is biking. That's how it goes. It should be pretty easy for you to distinguish these three actions. But there comes another person who plays golf. It gets complicated if the model needs to recognize the golf action. How can it be done here? We start to worry. The reason why I'm saying this is that this is how we have done with traditional programming. When we build a model to recognize something, we define rules, and if it follows the rule, then it is this, and if it follows that rule, it is that. If this is how we do it, the problem is when we encounter a new situation, it becomes a challenge to deal with. Let me give you another example like this: inputting an image of a cat. When we build a model to recognize whether an image is of a cat or not, what we need to do in a conventional way is to teach the model the features of a cat. For example, we have to teach the model that a cat's tail is long, and make the model find the tail. Of course, we also need to teach how to find it. And what's the minimum length of the tail? We can use if statements to do this. And with a cat's triangular and pointy ears, the model may look for the ears and recognize them as triangular and pointy. Define these rules, find every single feature and see if it fits the rule, and compare everything like the earlier example. The speed higher than a certain value is walking, and so on. So, we have to define all the rules, and if all the conditions are met, then it is a cat. Otherwise, it is not. We talked about a tail earlier, but the tail of a cat can be invisible like the image in the middle, right? Then, the rules become useless. We can face serious challenges in this recognition issue with the rule base, where we teach the computer rules and have the computer make a judgment based on the rules. So, we use a different approach in machine learning. Like what we just talked about, we set up the rules and input data. For example, lower than 4, put the speed here. In case of walking, a traditional programming model would give walking as the output, or give a cat image to the model and make it recognize whether the tail is long or the ears are triangular, and the output would be either it's a cat or it's not. Because of the limitations of this approach, in machine learning, we do it as we teach kids. When we teach kids what a cat is, we do not teach them a cat is a cat because of its long tail. We teach kids by showing them images of cats, right? Then, kids see the images and learn the features of cats, such as long tails, on their own. Just like this, we give images of cats to a computer and teach it that they are cats. It is like giving values lower than 4 and teaching the computer that this is walking. Put tons of data and give the computer correct answers every time. Then, the computer will find the rules on its own through self-learning. This is how it's done in machine learning. In the previous example of walking, running, biking, and golfing, let's say we put motion sensors on the body. Input data from the sensors and teach the computer that certain data translate into walking, this data running, this data biking, or this data golfing, and so on. Input a lot of data, and then without comparing the speed, The computer will judge on its own whether an action is walking or running with the inputted data. This process, where a computer learns by correct answers given beforehand, is called training. Another process, where a model that has completed learning is inputted with new data to make predictions, is called inference. So there are two processes, training and inference. When we say machine learning, it means the training process. What is actually important is how well we are able to predict based on the totally new data. Let's take the weather forecast as an example. If we trained a weather forecast machine with the past data, what is it that we want to achieve here? Accurate forecast of the weather. Accurate weather information of the past is meaningless. What is important is that we predict well with new data, not with the existing data. In order to do so, we have to train it well, input quality data, and make it a good model. We will be discussing further on this